Before we start anything, let's think about how we can solve this question. Here you can see the product of sec² x and ln 1 plus sin² x. So we can basically use the integration by parts method. We know the integral of sec² x according to the basic equation, but we don't know any specific equation for the integral of ln 1 plus sin² x. So we can give priority for sec² x. Clear? Let's jump into the question. Integral of sec² theta equals tan theta. So we can write integral of sec² x value as tan x. After that we can write ln 1 plus sin² x term as it is. Now minus integral tan x into differentiation of the ln 1 plus sin² x. Differentiation of the ln 1 plus sin² x we can write as 1 over 1 plus sin² x to sin x to the power of 1 into cos x. It is equals 2 sin x cos x over 1 plus sin² x. Tan x equals sin x over cos x. So we can cancel out denominator cos x value and numerator cos x value. Now we have integral sin² x over 1 plus sin² x. Numerator value sin² x we can write as 1 plus sin² x. To cancel out plus 1 we can put minus 1. After that we can divide 1 plus sin² x and minus 1 value from the denominator value 1 plus sin² x. We can cancel out denominator value 1 plus sin² x and numerator value 1 plus sin² x. After that, we can consider integral sign separately. First one, integral 1. Second one, integral 1 over 1 plus sin² x. Integral 1 equals x. Now, we can remove the brackets. We have tan x ln 1 plus sin² x minus 2x plus 2 integral 1 over 1 plus sin² x. Let's consider integral 1 over 1 plus sin² x. To simplify this integral, as the first step, we can divide numerator and denominator value from cos² x. In the numerator, 1 over cos² x equals sec² x. In the denominator, we can divide 1 plus sin² x terms from the denominator value cos² x separately. Then we have 1 over cos² x plus sin² x over cos² x. 1 over cos² x value equals sec² x. Sin² x value over cos² x value equals tan² x. Then we have sec² x over sec² x plus tan² x integral. Sec² x value we can write as 1 plus tan² x. Then we have in the denominator 1 plus 2 tan² x. 2 tan² x value we can write as root 2 tan x perfect squared. To simplify this integral, we can give a substitution. We can substitute root 2 tan x as u. Then differentiation with respect to x. Differentiation of the u value equals du over dx. Differentiation of the root 2 into tan x value we can write as root 2 into sec² x. Then we can cross multiply denominator value dx, and we can subject dx as du over root 2 sec squared x. Let's move to integration part. Instead of root 2 tan x value, we can substitute u. Instead of dx value, we can substitute du over root 2 sec squared x. After that, we can cancel out denominator value sec squared x and numerator value sec squared x. Denominator value root 2 is a constant. So we can bring 1 over root 2 value outside of the integral. Then we have integral 1 over 1 plus u squared. According to the basic integral equation, we can write 1 over 1 plus u squared integral as tan inverse u. Instead of u value, we can substitute root 2 tan x. Let's substitute this answer for the initial part of our solution. 2 value we can write as root 2 into root 2. After that, we can cancel out numerator value root 2 and denominator value root 2. Now we have final answer as tan x ln 1 plus sin squared x minus 2x plus root 2 tan inverse root 2 tan x.